adult stem cells to support the body's natural renewal system is poised to become one of the breakthrough discoveries of our time. To help understand the mystery of how stem cells and patented Stem Enhance work to create natural well-being is StemTech's Chief Science Officer, Christian Drapeau. As a leading authority on stem cell research and the co-inventor of Stem Enhance, Christian's ability to bring this complex science into clear focus has thrilled audiences around the world. Now get ready as Christian Drapeau unlocks the secret of the adult stem cell phenomenon.
Thanks for being here. It's a real pleasure to be here. Thank you. Thank you so much. Real pleasure to be here. Thank you for coming. What would you say if I were to tell you that there's a cell in the body that can travel, go to different organs, and become cells of a different organ? Now you've heard that message a little bit through StemTech, so it may not look that amazing. It's like a building block of the body. It's like a brick in a house. What if I were to tell you, you have a brick that will make the foundation, the wall, the sidewalk, the garage, the storage unit? What if I were to tell you, I have a brick here that if I have a problem with the sidewalk, I just put it there, it becomes the sidewalk. Or I put it in the foundation, it becomes the foundation. I have a problem in the garage, I put it in the garage wall, it becomes a garage wall. I break a window, I put it in the window, the brick becomes a window. Wouldn't it look a little bit like fiction? I mean, we would laugh at this whole concept. And yet, that is exactly what we have with stem cells. We have a stem cell that leaves the bone marrow, goes into a tissue and becomes cells of that tissue. It is of such a magnitude that I think oftentimes we don't fully grasp here what it is that science has discovered. And the magnitude of this is such that it was actually linked to the 2008 Nobel Prize in Chemistry. The Nobel Prize was attributed in 2008 to a small protein called green fluorescent protein. The development of the protein and also its use in medicine and in medical research. What is green fluorescent protein? It's a small protein. A protein is so small that it's invisible to most microscopes. So you have this very small molecule, virtually invisible, and if you put ultraviolet light on it, it starts to glow. So what was invisible suddenly becomes visible. So you have a few of these proteins somewhere in a place, and you put the light on it, ultraviolet light, and suddenly you start to see it. It's a little bit like, how did we discover the migratory patterns of whales? I know it's kind of far on the left, like different topic, but how did we do this? We put tracking device on whales, and suddenly we discovered, you know what? They migrate in places that we never expected, and they go at depths that we never expected. It is exactly the same thing here. GFP, green fluorescent protein, is a tracking device. The moment you put it in a cell, just like the brick or the whale that you track and suddenly you realize, my goodness, it's going way deeper than I ever thought. You put that tracking device in a stem cell and you realize, I have a liver cell that has that light in it. So that liver cell was a stem cell before. It's the same phenomenon, the same tracking phenomenon. That's what green fluorescent is about. It allowed so many breakthroughs in health and wellness and in medicine. And that's how the whole process here, the whole concept of stem cells was discovered, what they're doing in the body. We've discovered that stem cells can leave the bone marrow, travel to different organs, and become cells of a different organ. This is huge. This is called to change the way that we look at wellness, the way that we look at health. It's going to bring a paradigm shift in this whole industry of health and wellness. How is it going to do this? When we started with this whole field and studying, what became Stem Enhance, we did not know all of this. We were early on, and all of this was discovered as we went along. So we did not one day decide or realize stem cells is something that is really powerful, really interesting. Let's be the first one tapping into this whole concept. This is not how it happened. It happened when I started to study a plant, an aquatic botanical called Aphanizomenon Amphilos aqua. So let's call it AFA in short. I started to study AFA and tried to understand what was the mechanism of action behind its benefits. It was bringing a lot of benefits to people. People reported benefits touching the skin, better liver function, better pancreatic function, better cardiac function, cardiovascular function, brain function. What was really impressive and a mystery to us was the wide variety of these benefits. If a stem cell can become a cell of the brain or a cell of the heart, how could it be that this would just be some sort of a an interesting observation without a meaning. It's a little bit like you discover a seed, a little thing that you have in your hand, you put it in the ground, and it looks like a piece of dust, and suddenly you get a tree coming out of it. And the conclusion would be, oh, how interesting. And you just walk away without more thought. I mean, it will be unthinkable. It's a little bit the same thing. Here we see, wait a minute, a cell from the bone marrow can become a brain cell, a heart cell, and a liver cell? Why not a skin cell, a pancreatic cell, a bone cell, and every other cells of the body? If they can become a brain cell, most likely they can become everything. So we published in the scientific literature the proposal that stem cells from the bone marrow constitute the natural renewal system of the body. It was an idea 8 years ago. And now during those 8 years, data was filled in, a lot of studies were published. I'm talking hundreds of studies, basically confirming this whole concept. Stem cells do constitute the natural renewal system. Based on this idea, we went in the lab and we looked at the effect of AFA on stem cells. Before we get into it, let's talk a little bit about what are stem cells to understand the topic here. Stem cells are cells that are immortal and primitive. What does that mean? Immortal means that they will multiply endlessly. The stem cells in your bone marrow started the day that you were one cell in the tummy of your mother. That's where it started. And then it grew, they multiplied, and some of them stayed in the bone marrow, and they will continue to multiply until your last day. So they multiply like this, I say endlessly, but in your life, they simply continue to multiply during your entire life, contrary to any other cell in the body. They are primitive in the sense that they are nothing. They are nothing in the sense that they are not specialized, but they have the ability of becoming anything. Do you understand what that means? Let's compare them to what is not a stem cell. A cell of your skin, a cell of your muscle, your brain, your heart, the retina, the liver, the pancreas. A cell of your pancreas, for example, will make insulin. That's the only thing it will do. It will not contract like a muscle cell. It will not think like a brain cell. It's not going to beat like a heart cell. It's a pancreatic cell. A cell of your skin is not going to, if you go to the gym and you start to work out and you need more muscle cells, a cell of your skin is not going to think, gee, let's go and help that muscle below and sink in the tissue and become a muscle cell. It's not going to happen. They are specialized. They do one thing. They do not multiply. At the other end of the spectrum, I have stem cells. They have the ability to become anything and to multiply. That's what they are. They're found essentially in two places in nature. The first place is in the embryo. What we're talking about here is called the blastula. It is the very, very early embryo, 8 to 10 days old embryo. It is just 100 to 200 cells, and it is possible to extract the cells that are in this embryo that you see here in yellow. It's possible to extract, it's called the inner cell mass. It's possible to extract cells from this part of the embryo and to grow them in a test tube. Now, these cells are not all stem cells in that area. So you extract a bunch of them and you start to grow them. They will proliferate very easily, which is one of the characteristics of embryonic stem cells. But what is a key issue here, or a key characteristic of embryonic stem cells, which has become the test to identify if a cell is a stem cell, when I extract one of these cells from this embryo, the blastula, and I grow them, to demonstrate that it is a stem cell, I inject it under the skin and I get what is called a teratoma. A teratoma is a tumor where I have a few teeth, a piece of liver, a piece of stomach, intestine tissue. I even have what looks like a toupee, everything. So it's telling me that the cell that I injected had the ability to multiply. It went from one cell to this lump of tissue, but also it had the ability to become teeth, liver cells, heart cells, brain cells, functional cells, totally disorganized. It's a tumor, but it tells me this cell has an amazing potential. Now, keep that in mind because we'll come back to that. Now, the other place where you get stem cells is in the bone marrow, adult stem cells. Adult stem cells are from the bone marrow, though they can migrate in the blood, so they're easy to isolate from the blood, or as a matter of fact, we know today, from almost any tissue. You've heard that in the news. You can get it from the skin, from fat tissue. They're everywhere in the body, but they all come at the origin from the bone marrow. Okay, you look at them in a test tube, you try to grow them, they do not grow very easily. And if you inject them in the skin, they do not give you a teratoma. What was discovered is that in the body, not in a test tube, in the body, stem cells do proliferate just as well as embryonic stem cells, and they become any cells of any tissue, but the tissue where they find themselves. The embryonic stem cells will become tissue of everything in the lump. The adult stem cells will become cells of the tissue in which it finds itself. So when we talk about health, obviously adult stem cells suddenly become the real thing. This is where all the promise is in terms of health, because you want cells that become cells of the tissue in which they migrate. All this concept can be summarized essentially in this brief concept here, in this animation. So this represents essentially the blood circulation, and we have the bone marrow. It's obviously a schematic representation. When you have something happening in the body, the area that has the problem is going to start to release specific chemicals that have been well identified in science called granulocyte colony stimulating factor, GCSF. Forget about these terms, they're not important. But there's a compound very specific that is released. It migrates to the bone marrow, and when it reaches the bone marrow, it's going to start to trigger the release of stem cells from the bone marrow. Now these stem cells, when they're released, they don't know where to go. They're circulating everywhere in the body. They go everywhere. Sometimes I use this analogy. It's a little bit like if I take an apple pie fresh out of the oven and I put it somewhere here in the building and I tell you, go find it. What do? You don't know where it is when you start. You smell around, and when you walk in front of a room where the apple pie is, you stop and you say, that's here. And you enter into the room. Stem cells do the same thing. They circulate, and when they arrive in the tissue that has the problem, that tissue is releasing a very specific compound. Think of it as the apple smell, called stromal-derived factor 1, SDF1. When that compound touches the stem cell or reaches your nose, the stem cell turns around, and the mechanism here is that the moment that the molecule touches the stem cell immediately expresses adhesion molecule. So the stem cell is going to cling to the bone marrow, to the capillary, stop in the blood flow, and then will migrate in the tissue. And when it comes in contact with cells of that tissue, it is going to slowly become cells of that tissue, sort of replacing the tissue that is having the problem and bringing back optimal function in the tissue. That's what stem cells are doing in the body. Isn't it fascinating? It's an amazing process. And what I'm describing here in this drawing is taking place in the liver. The same thing is taking place in the brain. The same thing is taking place in the kidney. Same thing is taking place in the muscles. So it's essentially almost anything that they look at, they can find that the stem cells can become cells of that tissue. Here's a study where scientists took stem cells and they put them in a beaker on a mesh. The mesh was, so the stem cells here are in yellow, those yellow dots, put on a mesh that has holes that are big enough to allow molecules to go through, but small enough to prevent cells to go through. Okay, so you put these stem cells at the top, and at the bottom, they put a piece of crushed liver. So if you end up with cells of the liver at the top, it is not because cells of the liver migrated on top of the screen. They cannot cross that layer. This is a screen. It's a filter. It prevents cells from going through. When they looked at these cells on this mesh, 8 hours later, they were morphing, transforming themselves into liver cells. Now, understand why it took so long for us to see this phenomenon. It's because it is invisible. If I use the traditional mean of looking at a tissue, I take a piece of tissue, I slice it in a thin slice, I put it in a microscopic slide, and I look at it. What do I see? Liver cells. It is absolutely impossible to tell that yesterday that liver cell was a stem cell. It's impossible unless I can use something to tag it. And that leads us back to where I started, green fluorescent protein. Extracted from a deep ocean jellyfish, it is a protein that is spontaneously fluorescent. Because it is spontaneously fluorescent and because it's a protein, it's very easy. I mean, I'm making that easy. We're talking that Nobel Prize, 2008 Nobel Prize in Chemistry, was on a span of about 40 years of research. I'm making it look like it's nothing. But in theory, it's a protein, so it's easy to derive the DNA that encodes for that protein. Once you have the DNA, it's easy to inject it in a cell, in a stem cell. Now go back to what we were talking about just before. If I take now an adult stem cell that has that fluorescent protein in it, and I inject it in the skin, what do I get? I was looking with it to get a teratoma before, and I was getting nothing, so the conclusion is that they're not good stem cells. I get a patch of fluorescent skin. So the revelation here is that stem cells have the same adult stem cells, same ability, but the plus is that instead of becoming everything, they only become cells of the tissue in which they are. Okay? So, and here's what cells will look like when they do glow with the presence of that protein. So what normally would be invisible becomes visible. So it's the tracking device that we use to see where whales are going. It's a tracking device to see that the stem cells are going into these different tissues and becoming cells of these tissues. Here's how all of this is sort of coming together in a few studies. The study of Orlik, that was done at the NIH. So I'm using studies here that are extremely strong, coming from very credible scientific teams. So Orlik, what he did was very simple. He irradiated mice, which kills all stem cells. And then I inject new stem cells, but with that protein, green fluorescent protein. So you have green fluorescent stem cells. And then I trigger a heart problem, lack of oxygen in the heart, which leads to the death of part of the heart tissue by tying up the coronary artery. And then they came back and they looked at the animal 2 weeks later. And what they could see is that the portion of the heart that was affected was now fluorescent green. Meaning that these cells that are now heart cells today, 2 weeks after, they came from the bone marrow. But what is beautiful in this is that they reach the area and they become cells of the heart on their own. There's a beautiful picture of this phenomenon. What we show here is the picture of a muscle that was totally destroyed or killed on the first day of the study, and then we add the same protocol here with mice with fluorescent stem cells, and these cells on their own migrated in the muscle, and you can look, the muscle has been totally reconstituted, entirely green. It's a great picture to show here what we're talking about. The moment we have that tool, it becomes almost like child play to reveal what stem cells are doing in the body. So now, the number of stem cells. What would happen if I put more stem cells in circulation? What happens in the power of stem cells like this to repair various tissues? So the same kind of studies. I use two groups of mice. I trigger a death of the cardiac tissue by tying up the coronary artery. I split the mice in two groups. One group is control. I do nothing. The other group, I inject in the animals GCSF. Remember that compound that triggers stem cell release. So the two groups, the only difference, one group there's nothing. The other group, I have more stem cells in circulation for a few days. This was done for about 8 to 10 days. 27 days later, when they looked at the control animals, you can see that in the heart there was a lot of scar tissue. This is the blue that you can see. Lots of scar tissue, no new blood vessels, 17% survival, so 83% fatality, and then very, very compromised cardiovascular function. This is when nothing is done. In the animal who had more stem cells circulating in their blood, in the same amount of time, we're talking about roughly a month, total renewal of the ventricular wall, no scar tissue, new functional blood vessels tying up in the other ventricles, 73% survival, and quasi-normalized cardiovascular function. That study is telling us that in a month, there is a way, in a month, to reverse the consequence or revive a part of dead heart tissue. This is totally amazing. The reason why this protocol is not used as such in humans, it's because what is done here in mice gives severe, severe side effects in human. If we use GCSF for a little bit more, too long, more than 5-6 days, the consequences are heart attack, stroke, fairly severe side effects. So the idea of telling you, well, to help you from your first problem, we're going to give you, a heart attack. It's not a good trade-off. It's not a great marketing message. So these compounds are not ready to go to market, but they demonstrate a phenomenon that is very, very interesting. Now, GCSF is a powerful, powerful mobilizer of stem cells, meaning it triggers a vast release, a huge release of stem cells from the bone marrow. StemNNs that we'll talk about does not do that. So I do not want here to tell you that StemNNs will do this. What I want to do here by showing this is to show the power of stem cells, that if you really have a lot circulating in the blood, what you can end up in terms of repair is pretty phenomenal. But the key issue in here is the number of stem cells circulating in the blood. And that was captured by a study published in 2005. And now many studies have come out and have shown the same kind of results or the same kind of information, which is more stem cells in the blood equates to greater health. So if you have a little bit more stem cells every day, you simply allow the body to renew itself every day. So it's not about healing. It's not about anything phenomenal. It's a little bit like if I'm telling you, I am going to give you a month's supply in one day of food. Eat it all, and you'll be good for a month. Does that work? Now let's split it in 30 portion or 90 portions, 3 meals a day, a little bit, and then take that every day. After 30 days, you're in vibrant health and everything is fine. It's exactly the same thing with your stem cells. Massive release for a short amount of time is very different than just having a little bit more every day. That's what these studies are showing. So the conclusion is that bone marrow stem cells constitutes the natural renewal system of the body, simply supporting the release of stem cells from the bone marrow. Putting more stem cells in the blood allows to combat entropy or aging or just the natural process of life. You just repair everything every day. How can I see that this is happening in real life? Because everything that I'm talking about is done on rats and mice and cats and different animals. How can you make studies that and show that this is happening in humans? You can't. Okay, it's not ethical to study humans like this. But there is a real life situation where you can see it. That real life situation is when a man receives an organ from a woman or when a woman receives a bone marrow transplant from a man. In both cases, what do you get? You get double, because what is the main difference between men and women? Aside from attitude. I mean, women having the better attitude. I have to be careful here. It is the Y chromosome that men have that women don't have. Women have the double X, men have the Y chromosome. Just like green fluorescent protein, I can also tag the Y chromosome and follow it in a cell. So in that situation, I have the tissue. Okay, in that situation, what I have in both of them, I have the organ. Let's focus on the man right now. The liver comes from a female, from a woman, so it doesn't have the Y chromosome. But the men's bone marrow have the Y chromosome. In the other case, the woman's own organ don't have the Y chromosome, but the new stem cells have the Y chromosome. So if this is a true phenomenon, stem cells should leave the bone marrow and go to any organs. In the case of men who received a liver as a transplant, what they did is that they went back into bank of biopsies, samples of tissue taken after a transplant if there were any problem, and they just analyzed these tissues for the presence of Y chromosome. And what they found is that between 4 to 12 months, these were the people involved in the study, up to 16% of the liver, of the cells in the liver, had the Y chromosome. 16% of the liver had already been replaced within that time period. But one individual who passed away after 4 months and a half of serious complication, 40% of his liver was his own liver, made of his own stem cells. Okay, now let's look at the data that we have on stem enhance, which is the work that we have done. Everything that I'll be talking about was published about a year ago in a journal called Cardiovascular Revascularization Medicine. We gave people AFA and we quantified the number of stem cells in the blood. First, we didn't see anything, but it was such a great idea, so we kind of kept working on it. And one day, we started to give people more and more. And when we start to give people more than 5 grams a day, then we start to very consistently see this effect. An increase in the number of stem cells of about 25%, 25 to 30%. That would peak at about an hour and then come back to control. So the effect was there. But because people need to take 5 grams, it is something that is very difficult to market. If we tell people, well, take 10 to 20 capsules 2-3 times a day, it's not very easy to do. It would be like consuming a bottle of capsules every day. So we had to identify the active compound, how it's working, what it does to explain this whole phenomenon. So that's what we did. So in the bone marrow, so this is to represent a bone, with in red the bone marrow, the cell, and on the surface of the cell, a protein called L-selectin. When L-selectin is activated, it leads to the expression of a baseball glove called CXCR4. It's a receptor. It's a receptor that is specific for a molecule called SDF1, stromal-derived factor 1. If you remember well, SDF1 is the molecule that is released by an injured tissue to call for help. So the same phenomenon taking place in an injured tissue takes place naturally, without injury, without anything. It's just natural health in the bone marrow to keep the stem cells in the bone marrow. When these two connect, so SDF1 with CXCR4, the receptor, it leads to the expression of an adhesion molecule that makes the stem cell grab the bone marrow and stay attached to the bone marrow. Anything you do to prevent or interfere with this phenomenon, you will trigger the release of stem cells from the bone marrow. We thought we probably have in AFA a blocker of L-selectin, that molecule here that is at the surface of stem cells. If we have a blocker of L-selectin, we block its activation, we don't have the expression of the receptor, we don't have the connection, we don't have the adhesion molecule, so the stem cell loses its ability to hang in the bone marrow. So far, so good? Okay. So how did we determine if we do have something that binds to the L-selectin? In science, a ligand is a molecule that binds specifically to something. That's what a ligand is. So we thought we have an L-selectin ligand in AFA. An idea. We don't know if we do have one. So what did we do? We essentially, it's an ingenious protocol I did not design, Dr. Jensen did. Took a magnetic bead covered with a protein, specifically that is kind of a glue, and in it we stuck L-selectin molecule. Now, I show only one here, but think of it as a hairball where you have, hundreds, if not thousands, of these little L-selectin going around. It's a magnetic ball, so if I put it in water, it's easy to put a magnet, and they all stick to the magnet on the side, and then I can collect them. Okay, so what we did is that we took this magnetic ball with the L-selectin on it, and we put it in a solution of AFA. If I have something that binds to L-selectin, I'm going to collect it on the L-selectin molecule. I don't know if I have it. So what I do is I put it with AFA, I wait a little bit, I put my magnet, I collect all these beads, and then I wash the liquid thoroughly until I have pure water, and then I remove the magnet, so I have these beads now that floats into pure water with or without a ligand that bound to it. Remember, I don't know. This is a study that I do to determine this. So now I have this bead with or without the molecule. There are ways to cut this bond so that molecule gets released from the L-selectin. So I do these techniques, I release that molecule, then I put the magnet again, collect these beads, and now I take the liquid. So in that liquid, if there is a molecule that specifically binds to L-selectin, I have isolated it. We have determined that we have in StemEnhance a ligand that binds to L-selectin. It could be an activator or a blocker. Through various studies, what we have shown is that it is a blocker. It does not activate L-selectin, but it prevents the activation of L-selectin. So when we concentrated this compound and then turn it into a product that is now known as StemEnhance, and then we feed this concentrate of AFA to people, we get the same release of stem cells from the bone marrow with the same increase in the number of circulating stem cells of about 25 to 30% with only 1 gram of StemEnhance. That's the work that we have done, identifying the active compound and then concentrating the product so that we can, with 1 gram, get the same effect. As we were doing all this work, we also discovered something. It was a puzzle. It took us 2-3 years to do this work. It would have been much easier had we known this when we started. We have 2 compounds in AFA that affect stem cells, and they have an opposite effect. So think about this. I mean, not easy to resolve this puzzle, but at one point it became very clear, and we did identify these 2 compounds. There's a compound that blocks L-selectin, and there's also a polysaccharide that supports the migration of stem cells out of the blood into the tissues. So as you consume this product, the number of stem cells in the blood actually decrease as stem cells leave the blood to go into the tissues. So you have the graph here shown by both. So what is StemEnhance? It's a blend of these 2 compounds, these 2 concentrates from AFA, the L-selectin ligand or blocker, and then the polysaccharide blended. So 1 gram of StemEnhance supports both the release of stem cells from the bone marrow and their migration into tissues. Now, there's an easy way to summarize all of what I've talked about right now in a very, very, very simple message. Think of health as a balance between 2 phenomena in the body. I have, on one hand, entropy, which is, let's call it aging, going down, slow breakdown of tissue. On the other hand, I have rebuilding, which is what your stem cells are doing. Your health will be determined by what is going on in the body. If the rate of aging going down is bigger than the ability to rebuild, you experience unwellness. If your ability to rebuild is greater than how fast you go down, then you will experience wellness or health. Cells die every day. It's a natural process, totally natural process. Stem cells replace these cells every day. It is a natural process. The faster you go down or the faster you rebuild will determine your overall health. And what will determine how much you go down? I will say it's the sum of a number of things. Your genetics, your past injuries, your lifestyle, your diet, your exposure to environmental toxins, your level of stress, your mother-in-law. Put all of that into a bag. Shake the bag. That is the stress applied to your body, for which stem cells need to sort of rebuild or make up for. So if you have more stem cells in your body, you will just be able to have a greater health. That's what Stem Enhance does. All it does, it doesn't heal anything, it doesn't cure anything. All it does is that it promotes rebuilding so that you improve and you experience wellness. A question that often comes is it safe for the bone marrow to constantly release stem cells like this from the bone marrow? There's a powerful mechanism in the bone marrow to maintain homeostasis, a specific number and constant number of stem cells. You don't run out of stem cells. Stem Enhance does not trigger a release of stem cells that is beyond what your body already naturally does on its own. We need to understand that in the body, what happens, the way that cells divide and maintain themselves in the bone marrow is a different process than elsewhere in nature. Everywhere in nature, what we have is cells divide through a process called symmetrical cellular division. I have one cell that divides into two identical daughter cells. What happens is that the DNA makes a copy, and then one piece of the original DNA goes in each cell, a piece of the copy goes in each cell, so you end up with two identical cells that have one piece of original, one copy. In the bone marrow, it's different. In the bone marrow, you have what is called asymmetrical cellular division. The DNA duplicates, but the original goes into one cell. That one stays in the bone marrow. The other one, the copies goes into the other cell. That one goes in the blood. That cell is destined to travel and become a tissue cell. This process is meant to basically keep in the bone marrow your original DNA that you had from the day you're born. You'll have it until the day you die. And the reason why I'm talking about this is that anytime a cell goes into the blood, a sister cell was left in the bone marrow. So what we talked about before with Stem Enhance, 25% increase is roughly 3 million stem cells being released in the bloodstream. That's a fair amount of stem cells. Well, it does not mean that now you're lacking 3 million stem cells in the bone marrow. They've multiplied. So you basically keep the same number of stem cells in the bone marrow. The bone marrow is this powerful way of maintaining balance and homeostasis. Now, over the past 2 years, we have done a number of studies to extend the information that we had on Stem Enhance. The first one, very interesting, is do the released stem cells reach the target tissue? Why is this question pertinent? It's pertinent because what I have on one hand is the information pertaining to many hundreds of studies that are not about Stem Enhance. They're about stem cells in the body, GCSF, and all of these other products. But I know from these studies that more stem cells in the blood equates to greater health. I have a product that I can show increases the number of stem cells in the blood. So I put the two together. It is a legitimate claim to say the product, by increasing stem cells in the blood, will help overall health. But there's a point where I need to show that Stem Enhance itself does not only increase the number of stem cells, but these stem cells released from the bone marrow do indeed go to tissue, and the whole story is true. So that's what we did soon after. It's the first study that we did to basically prove the concept and link all of it together. So very simple study. We irradiated mice, kills all the stem cells. Again, this is a kind of study that you cannot do in any other way than to do it in animals. So we irradiated mice, injected fluorescent stem cells. So we have a normal mouse whose stem cells are green fluorescent. So if they move and go into any tissue, we will have cells of that tissue that will be green. Then, so it repopulates the bone marrow. Then we do an injury to the muscle by injecting cardiotoxin. It kills the muscle. And then we basically split the animals in two groups. One group control, one group on Stem Enhance. Quite simple. And then we're looking at the recovery. And we can do that by taking whole body picture of the animals without having to touch the animals. So you can follow the recovery. And 6 weeks later, what we got is a number of things very, very interesting. First, if we look at the control animal, you can see that the muscle has regenerated quite significantly. You can see the muscle has come back. But when you add Stem Enhance in the diet, the recovery is much greater. So we're proving the concept here. Putting more stem cells in the bloodstream will lead to a greater repair. But it does demonstrate the other part of our story, which is just as important. It is a natural process. Without doing anything, it happened nonetheless. Stem Enhance just make it faster and more powerful. And it also demonstrated the third part of our concept, which is when we looked at the other leg, the left leg, that did not have an injury. we see very, very little migration in the muscle. It happens naturally. It happens more when you have more stem cells, and it goes where you have the injury, not where you don't have the injury. So it's a very directed process. So that study really showed those three pillars, if you want, of our whole concept. So one way to capture everything is by a tool called a quality of life questionnaire. The questionnaire is a very simple tool aimed at assessing your quality of life. And the study published 15 years ago concluded that by simply asking you how do you feel, it is much more powerful to determine what's your problem and to help you recover optimal health. So it's essentially to determine what is your overall quality of life. If your liver functions better, you have better quality of life. Your pancreas works better, you have better quality of life. Your brain is better, better quality of life. Your joints are better, you have better quality of life. So all of this can be captured by quality of life. So that's what we did. We did that questionnaire. You can see a sample of that questionnaire at the website, Am I Healthy? You can do the questionnaire. There's a sample there. It will tell you how you compare with the overall national average of health for your age and everything. And then you can basically see, as you take StemEnhance, how it changes your overall quality of life. But that's what we've done. And this is a typical report that we get. That's a difference in 1 month. So we basically took the results on day 1, and then 30 days after being on StemEnhance, and we have the percentage difference on 10 different parameters: general health, physical functioning, your ability to bodily pain, vitality, social functioning. For example, the questionnaire will ask you, instead of saying, are you depressed? They will ask you, how many friends have you seen this week? If you're depressed, it's 0. If you're full of joy, it's 10, 15, 20. So by a lot of these indirect questions, they can determine your quality of life in a very, very scientific way and very, very valid way. So on average, everybody, on every single parameters, we have an improvements within only 1 month. So essentially, what this study is telling us is that when you confound everything, you take everything under one big umbrella, everybody experience some level of improvement in quality of life after 1 month. So it was a very good study here to capture what the product does as a whole. Hair study. When we launched the product, a lot of people started to report within the months following that they were slowly returning to their natural hair color. At first, I thought that the report, the testimonials were sort of silly. I actually didn't like the story. I was telling people, don't exaggerate anything. Don't say things that are unreal. Just stick to the truth, and it's strong enough with what we have at this product. We don't have to go into any kind of exaggeration. And then one day a friend of mine came in and says, well, it's really happening to me. And then it started to happen to me. So we contracted with a lab in cosmetology, and first what I did is that I went on Medline, which is the library of the National Institute of Health, and I plugged in adult stem cells and melanocytes, the cells responsible for hair pigmentation. Fair enough. Documentation exists, stem cells can become melanocytes. So, you know what? There was a basis to this. So we went to a lab of cosmetology, and on 6 individuals, we followed using very sophisticated tools of taking pictures of the hair and analyzing the color, essentially, the density of white in the hair, and following this over a number of months by taking StemEnhance. Like this fellow that you see to the left, his head was entirely like pure white. And as you can see right now, it is not totally pure white. But what was interesting is that when you look in from the back, there's a row of black hair, and in the center of his head where he had a crown, he's starting now to have black hair growing. So it's cases like this that prompted us really to look at this seriously, because it was really there. So what we discovered is that after 6 months, when we take picture of the back of the head, there was a 15% reduction in the white density in the hair. So there was a 15% darkening of the hair. And here are a few pictures. This one is not so obvious, but this one, for example, is fairly obvious. And then we took pictures on the side of the head, and this one we had a 20% reduction in the white in the hair. And you can see it here in these different pictures. So talking about hair color is not in itself relevant to health. Hair color is not in itself anything that means anything important, when we talk about health. But it does have an amazing symbol. What else do we have in the body as a symbol of rejuvenation? What do you know that you can take orally that is going to reverse to your natural hair color? Nothing is known to do that. So to take something that is so powerful in the body in terms of rejuvenation to give you back your original hair color is a powerful message, and hair color is not a disease. Graying hair is not a disease. So we can use that message without any problem with the FDA, without talking in any way about disease. And that's the reason why we did that study. We will come out with that report. StemEnhance is the only product known to have such a rejuvenating effect in the body that you reverse back to your natural hair color. I think it's powerful. That's why we did it. Now, in the scientific literature, you've seen it in the press, a lot of people are talking about how stem cells could be the cause of cancer. Answering that question with arguments would not really lead us anywhere, so essentially we did a study. Very simple study to just clear the whole question. We inoculated mice with human breast cancer cells, and then we split the group in two, and then one group we gave control, nothing, or a placebo, and the other group we gave StemEnhance. Now, three things can happen. Stem cells or StemEnhance, by increasing the number of stem cells, these stem cells can migrate in the tumor and promote tumor growth, so we could have increased tumor growth. We could have no effect whatsoever. Or we could have a decrease, because one thing that people don't really talk about is that when stem cells get into a tissue and they proliferate and then they stop proliferating, they release compounds that calms all the neighbors around to sort of stop the proliferation process. Now we're done. We have repaired the tissue. It's time to stop. So they could also, through that process, suppress tumor growth. So we could have these three options. So we did the study, and as you can see on this graph, after 6 weeks, we had a 30% reduction in the growth of the tumor. Now, that study was not made to determine if StemEnhance has anti-tumor properties. So that conclusion I cannot make. But what we can clearly make out of this study is that StemEnhance, or releasing stem cells from the bone marrow, do not promote in any way tumor growth. If anything, it prevents it. Okay, the last one that I want to talk about is a study on fitness. Many people start to talk about how, from a physical performance standpoint, started to report much better performance. And we have our notorious case, Frank Condon. You may have heard the story. Frank had his own record when he was 57, and it could not change it for a number of years. At 63, if I remember well, started to take StemEnhance, and then beat his 57 years old record. If I remember well, it was by many seconds. I think it was 10 seconds. He's doing like the 1,000 meters, 1.5 kilometers, long distance, not the dash, but not the marathon, somewhere in between. There was a video on the web of one of his races. It was very impressive. You see the racetrack, and then you see Frank crossing the line, the finish line, and in the background, half a field behind, you see the rest of the people running behind. It was fairly impressive. So at 63, he beat his record at 57. At 64, he beat his record at 63. And at 65, he beat his record at 64. That was after an injury that was supposed to put him off for the rest of the season. He just repaired very fast, went back, and beat his record again. So a lot of people start to report those kinds of stories. So there's a process here. When you push your body a lot, you break muscle fibers. When these muscle fibers are broken, there's a mechanism to protect the muscle that is inherent to your nervous system so that you're not going to overcontract that muscle and further damage it. So if the damage is fine, like it's not huge, there's a little bit soreness, but not more, you go back the day after and you train again. But you cannot train to the fullest because there is an inherent mechanism to prevent to go to full contraction. If you can repair much faster and recover faster, 2 days later when you go back to the gym, you can go to the fullest. 3 days later, 5 days later, and so on every day. So over time, you just get a much greater outcome out of your same training. That was the concept. So we went in the lab and we tested it. When we started to talk about the study, and we tell them, we'll put you on StemEnhance, they started to look at StemEnhance, what it was, and when they slowly realized what StemEnhance was, we could not have any one of them on placebo. They said, if I'm not on StemEnhance, I'm not part of that study. So we were not able to have like a placebo group and a StemEnhance group. So we tried to think of how can we work that in so that we can clearly see the effect of StemEnhance compared to the effect of the training. So what we did is that we split the group in two. One group started on StemEnhance on day 1, and the other group started a month later. So if there was a difference, we would have the first group progress faster, and the other group reach them up in their progress a little bit later. And that's exactly what we saw. You can see the group 1 here progressed much faster. And then group 2, as soon as they started to get on stem enhance after about week 4, week 5, then they slowly reach back the other group. So we're using that data as preliminary data because it's strictly preliminary data at this point, but we're using this to basically go now and sponsor a large study in a lab that has that very specific expertise. So that's the body of the information that I wanted to share about stem enhance. What it does in the body, how we've proven the concept through various research, and what has happened outside of what we have done throughout the entire scientific research, what other labs have done. This is, again, a powerful, powerful phenomenon that is called to change the way that we're looking at health and wellness. I see it just 2, 3, 4, 5 years down the road. The message that will be out there in health and wellness is that, yes, many things that we're doing is good for health, and we continue to do them. But the primary thing to do to maintain health is just to support that natural renewal system in the body every day. What it is that I think a lot of health problem that we experience is actually a deficiency, a lack in the stem cells to do simply their day-to-day job. If we do not rebuild, compensate for this every day, at the same speed as they go down, health problems show up down the road. And that is the cause of an awful lot of unwellness in human life. Once we understand this and we just support this natural renewal system in the body, it's going to totally change the way that we look at health and wellness. So, thank you very much.